Hey guys, this is Gabin once again, and today we'll be working on some logarithms questions, right? So in the previous video we talked about logarithm and we talked why they're so important. And then really, if I want to emphasize this, logarithms are so important because they facilitate on how easy we do calculations, right? So imagine you're stuck with indices or something like this, and there was no any other method to solve this type of question. And Johnny Napier was like, nah, let me get something that we could use to facilitate this type of questions. And so that's why he invented logs. Now, some of the properties of logs that we'll be looking at. Okay, before we start, so log x, most of the time you will see that they don't put the 10 here, which basically they assume that it's already 10. So log x, when it's written like this, is the same as log of x to the base of 10, right? And ln, so this is another relationship. Ln x is the same as log x of base e, right? Log x of base e. So log x of base e, and e is an exponential number which is approximately 2.71828, right? And some of the properties of logs that we'll be looking at is I've got log x times y of base a is the same as log x base a plus log y base a, right? So you see the base is the same, the base does not change to any of them when you just distribute this product here. The product here is the one that we distribute, right? So product become addition, and division in the other hand becomes subtraction. And yeah, so let's see if we could solve this question and see how we can do it. Now, so the first question, pretty much the first thing is to analyze what you were given and to analyze what you're asked to do, right? The question here could be simplify or solve, right? So if you say simplify or solve, basically now, given that we just saw these two properties, let's use them and let's apply them and see if they can help us, right? So we've got base log, this is just log 25 or base 10 plus log 4 base 10. Now remember the product rule here that we're using, so because it's addition, that means you can transform this into product. And the way you will do that is you take, so this is the same as log of 25 times 4, 25 times 4, right? So, and on my next line, what I'm gonna have log of that, and then 25 times 4 is 100, right? Now this is a crucial part, because as I mentioned, there is a 10 here, there is a 10 here that we are not putting, there is a 10 here that we are not putting. So because we are not putting that, what I'm gonna do, I'm gonna transform this, I'm gonna transform the 100 to make it to the base of 10, right? To make it to the base of 10. If you haven't watched how to solve this, watch the previous video where we looked at on how to do it. So because there's a 10 here, I'm gonna write 100 to base of 10, right? So how can we do that? We then have that this and the 10 squared, because we know that 10 squared is the same as 100, right? And another property of logs that you'll be seeing a lot is basically when you have the power, you are allowed to do to take the power in front, just the power in front. So you have 2, and then you have log 10 of 10, right? Believe me, log 10 of 10 is just 1. Log of 10 of 10 is just 1, and then your final product, your final answer is just 2 times 1, which is just 2, right? So 2 times 1 is just 1, and yeah, so final product here is just 2, right? So I hope this example is clear, but then I've got a few other examples. Let's go through them and see if we can get a match done, right? So this was one of them. What was the other one? Okay, cool. What I'm gonna do is that. Alright, so example 2 is log of 16 base 4, log of 16 base 4, log of 16 base 4, right? So in this one, what do we do now? The first thing, as I mentioned, you have to analyze what you're given. If there's no product, it's okay. And the second part is you have to analyze your base. Is your base related to 64? So our base is 16 in this case. Is 16 related to 64? Right? If you can't think of what number could we do, or could we raise, or could we raise to the power of 16 to get 64, then that's okay. Maybe you have to think of the product rule that we just saw. So this, if I want to be slow, this is what we'll do. I would have log of base 16 of maybe half 16 plus plus 16, and we know that this will give me 4. Why? Because of the product rule. The product rule says when you are trying to add these two, these are the same as log of 16 times 4, and 16 times 4 is 64, which is in this case is the same. I'm just expanding that. And what this allows me to do is it allows me to have log of 16 base 16 is just 1. Right? What number can we raise to the power of what number can we raise to the power of 16 to get 16? Just 1. Right? So here I'll have 1 plus. Now on that side, this is very important now. So I like that's 4. Right? That's 4. How can we write 16 to the power of something to get 4? Right? Now there are a few ways that you could do. We know that these two numbers are related somehow, because we know that 4 squared is 16, right? And we know that square root of 16 is 4, right? So given that, we know that what we could do to raise this number to 4 to make it 16 to get 4, then we could do this 16 square root of 16, because the square root of 16 is 4. And on my next line, I'm gonna have 1 plus 1. But then how do we write square root? So this is the same as 16 to the power of a half, right? 16 to the power of a half. And as I mentioned, you allow with one of the log property, you allow to take the power in front and keep the rest as it is. So in that case, what I would then have 1 plus a half in front, and I have a log of base 16 of 16. And as we saw earlier, this is just become 1, and you then end up with 1 plus a half, which if you wanna or write them as a fraction, you're more than welcome to do. You have 2 as a denominator, 2, this will be 2, 3, right? Yeah. So I hope this example is clear enough. If I go another example, yeah, I've got one more example. It's okay, I will do in the next video. Thanks guys for watching. Thanks for your support, I really appreciate. And remember to like, share, comment and subscribe as well if you haven't done so. Thank you.